Hello, everyone. Yeah, hi. So, good evening, everyone. This is the 11th week of Introduction to Machine Learning, and today I'll be dealing with naive Bayes classification with Python. So, in our very first class, we learned about naive Bayes and different probability theorems and algebraic theorems. So, that time we just read about how mathematically things are done. So today I'm going to let you know in real life how the real life problem will be related to naive Bayes theorem, probability theorem, and how you're going to deal with them using Python. Okay, so I'll just show the code link. Yeah, the code link is in chat box. I'll show my screen. Just before I can proceed, just confirm me if I'm like my screen is visible. Is it?
Yes, ma'am. Screen is visible.
Okay. So, as we know, bias classifier, how bias classifier is used in machine learning. So, I gave you example when where we need to find, true positive, false positive. If like a test has been done, that if the person has been tested positive is actually positive, or it has been false negative, something like that, right? So, in simple, bias classifier is a probabilistic classifier, and it depends on the existing of particular feature of class, and which is independent or unrelated to existing features, which means it just depend on the features on which it is being worked on. So for that I have taken an example. So this example is about, um, think about it. You have to catch a train from one, like you're traveling by a train, and from one destination to reach to another destination there is a connecting train, which means you have to take another train. So for that you have to, your first train should arrive at particular time or before time the your second train left the platform, right? So this is the example of city in Hamburg, Germany. So suppose you are traveling from Hamburg to Munich via Frankfurt. Okay, so your connecting train is via Frankfurt. So now your Frankfurt train to be on is already on time. So you have to take a Hamburg train to Frankfurt so that it should reach on time to catch your another train which is from Frankfurt to Munich. Okay, this is our example. So the connecting train will not wait for more than five minutes. This is the example which has been given. The following list in time the train from Hamburg arrived in time to catch the connecting train to Munich. That is, in time is what it is. Train from Hamburg arrived in time to catch to Munich, which means it arrives on time. And too late is means that you have missed your train, the connecting train. So this is what the data is being shown. How you're going to find out that machine learning probability using this, we'll see that. Okay, the first component of each tuple is this, the big bracket you can see now. In big bracket there are so many different numbers, so that big bracket is called as tuples means the sections of parameters or numbers or information, whatever it is. So the first component of each tuple shows the minute the train was late, and the second component shows the number of time this occurred. So this means this 0 is your minute and 22 is number of time. Okay, so this means it has been on time 0 minutes, and how many times it has been on time? 22. 1 minute, how many time number of times it has been on there? 19. And too late is what it is? Delayed time of train 1 and number of times again. Okay, so this is what your information is about. Now we will see, this is the data set which has been provided, a data set that has been created. Okay, so my second problem would be, I need to plot a matplotlib. I need to firstly see how many times the trains are in time and too late, because the data set which has been provided looking just at the numbers is more clumsier, and it's not very much convenient, rather than if we want to see it in the terms of any graphical, right? So remember my class with the EDA. Okay, so it's similar to that, that how we can see our data, how we can visualize our data. So what I've done is, just I have plotted in time and too late both the data set that has been provided in terms of your this part. Okay, so this is what you can see. Okay, we can see this blue is in time and red is too late, and this the red, the extra red you can see is how many. Okay, so this extra red you can see that how it is overlapping, that it is coming on time. Okay, that's it. Okay, so yeah, which I have written that from this data we can deduce that the probability of catching the connecting train if we are on 1 minute late is 1, because we had 19 successful cases experience and no misses. Remember, what we are dealing with is probability, right? We are, it is different from other programming things what we have done. So we are talking in terms of probability in Python. So you have to keep that in mind. So that is what it is telling, that we can deduce that the probability of catching the connecting train if we are 1 minute late. Okay, because we had 19 successful cases with no misses, right? Matlab, no misses means we have not missed our train. So this is what does it means, 1 and 19. Okay, for the in time thing. Yeah, that is, there is no tuple with 1 as the first component is too late. We will denote the event train arrived in time to catch the connecting train with S. So we are writing if my train is coming at a particular time on time. So we are connecting denoting it as S, that it is success, that we are success. And unlucky event train arrived to late to connecting the connect train with M, that we have missed a train. Okay, so that this just remember S and M. So S is success, that we are able to catch the connecting flight, and M is we are missing it. So now we are creating the dictionary. Dictionary as in tuples is like in brackets what we have data, right? Dictionary is something which is in order, in line, like a series of line. Okay, so we are creating a dictionary for in time and too late, and my data is in minute, right? So I need to check how we are going to check if my train which is coming is on time or late in terms of minute, right? So how it is on time, or how many minute it is late, and because of that we can tell it is late. For example, I'll give you, if your connecting train is leaving at 9:05 and your train reaches at 9, so you're 5 minutes early, so it means you are on time, right? So it means there is success of catching your tire train. But if your train leaves at 9:05 and you reach by even 9:07, you're 2 minutes late. So that is what in terms of minute we are talking about. Okay. Okay, so what we are doing is we are creating a if and else term, where if I'm saying if my S is equals to 0, which means if it is coming on time, then success is, if success is 0, return 0. Else if you're missing it, then how many times, how long you have missed it. Okay, so that is divided S by S plus M. So you know how we calculate the probability. So probability is like the event which is happened divided by total number of event, right? So that is what we are doing. Event, that is S, that is success, divided by total number of event, S plus M. Okay, yeah. So this is this minus 1, 1.0. So this 0 to 12, this is the number of times the train is either coming on time or not coming on time. So this is what the probability it is giving. This 1, 1, 1, this is means 100%. 0.6 means it 60% yes, 40% no, something like this. Okay, so this is what in probability we got the result. We will see. Now I'm taking another data set which is a person data.txt. So it contains 100 random person data, male and female, with different body sizes, weights, and gender tags. So what it is, we have a different, so the first one is done, right? With the help of this we can tell you ki this is the probability you are able to, like, what I meant is, uh, uh, these till 0 to 500% probabilities that you are able to catch a connecting flight. For 6 1 it is 60% probability. For the 7 1 this is the probability. So what I have calculated is the probability that you will catch your train or not, right? So now I'm taking another data set, which is a person data.txt. So what it is doing, it has a different set of data, which is male, female, their body sizes, their weights, and gender tags. Okay. So if I can show you the data set, wait, I'll just try to show you the data set. So maybe with that you can get an idea how the data set looks like. See, on my right hand side, you can see this is the data set, how it is. So this is the name, Randy Carter, 184, 73. So 184 is your what? Body size, 73 is your weight, and either it is a male or female. So this is how your data set it is. Okay. Yeah. So now I'm opening my data set. I'm what I'm doing is I'm splitting my data set into different categories, because right now you can see is it's just in one form. There's no separate columns for that. Okay. So for genders, in gender, what I'm doing is, firstly I'm taking first name gender. That is what I'm taking the name and the gender, what the gender is. Then again I'm taking the height of that gender, and because the categorization is in the terms of male or female, and then their body weights, body sizes, right? So that is what I'm doing is, so now I'm printing, if it is gender then print female, and it is, if it is first name and gender, then it is a female, and then print height and gender. So they see, for the female we have the name and its height, name and its height. So all the different females where names has been taken and their heights had been taken. Similarly, all the weight, all the male names has been taken and their heights has been. That is what segregation has been done with the data set. Okay. Now I need to design a feature class. So that is how we are going to calculate our probability. So we are creating a feature class. For the feature class need a label like height or first name, right? So if the feature values are numerical, we may want to bin them to reduce the number of possible feature values. The height from a person have a huge range, and we have only 50 measured values, that is male and female, because we have already segregated what are our male uh, and their names, female and their names, so their height and body weight will also be segregated, right? So we will bin them into ranges 130 to 134. So we are taking a categories. So 130 to 134, if this is the range it belongs to, then it is a male. 135 to 139 it is a female. 140 to 144 it is a male. So how many number of female belong to this category, number of male belong to this category, that is what we are doing. That is what binning means. What I meant is that when we do a survey, what we do is we take a category wise, like how many children belong to the category from 10 to 19, we count it as teenagers. 19 above to 25 we count it as youth, or 28 we count it as youth. So we are binning it. So that is what binning term means, and so on, by setting bin width to 5. So we are taking what bin width is fixed, that is 5. Okay. There's no of way of binning the first name, so bin width will set to none. Obviously you can only set the numbers to bin width, right? You cannot set names, because names are always different for all these. Even if it is same, you cannot categorize it in one category. Okay. So that is what this means. So the method frequency returns the number of occurrences for a certain feature value or a bin range. Okay, we'll see that. So what I've done is, from collections import counter. So there's something called counter which counts every time we do a binning, like how many times this has been come, how many times this has been come. That's it. NumPy as NumPy because we need to work on the numbers, right? Now this is called initialization. So we are initializing our data, bin width which is not required, name as none, because we are not using the name for binning, right? So that is why it is all none. Okay, name and bin width. So self dot name means whatever the name is, just call it that only. Whatever the bin width is, call that only. Now we are dealing with that we are giving the bin size, np range, minimum of cell mean. So whatever the minimum value is, take that and then divide it with bin width. Okay, and we are basically just calculating the percentage or how many you know number of times this person, like for example 10 to 19 if the category we are keeping, so how many children are there into 10 to 19 category? So we need to count again and again, right? So that is called frequency. How many frequently the number of persons or the number of children come into that category. So that is what frequency means. And there's something called histogram. So we are creating a histogram with that thing. Okay, yeah. So now we will create two feature classes, feature for the height values of the person data set. One feature class contains the height of Nayar's base called male and one height for the female. Obviously, that is what our final category is. We need to know how many males and their categories, female and how many are categories. Okay. So what we are taking is for genders in genders. We are taking height as gender, name as gender, and bin width we have kept as five, right? So we need to know that, for example, 155, if the 155 uh, like height we are taking, so how many male belong to that category, how many female belong to that category, something that is what we are counting. Okay, so see, that is what we have done. So 155 one male we have, 165 male we have, similarly 168 female we have. So these are the numbers which we are counting. Okay, so this height, how many people belong to that, and that is how we are categorizing male and female. Okay, now again the same thing. This is what it is like in the terms of numbers. We want to represent it in the terms of bar chart, right? So we are plotting a bar chart as well. So just to plot the bar chart for the same, I got some error. Why plot bar is not defined? Let me just check. Called matplotlib. Yeah, I have. Give me a minute. Yeah. Okay. So this is what the representation is. So what we are presenting is this blue line represent the male and the red line represent the female. So this extra, the lines are coming, right? So don't worry about that. That is like we have set a curved line that how many should be there. So that is not, even if you don't put it, that is not even required. So that is the bar width which we have put, that bar width is equals to 4 if gender is equal to male, else 3. That is it. That is not at all required. So we just wanted to see how many female and male belong to these 130 to 200 the height categories, right? So what we can see is maximum is what for 165, middle one is 165, right? So females maximum is in 165 height. Okay, that is what we are seeing. Now we have to design a Nair bias class. That is what we are working, right? So
Hello,
we,
ma'am.
yeah,
Ma'am, why we have selected being with only five means we
sorry,
can
can you repeat? I
why
couldn't hear you.
why we have selected being with as a five means we can select more or less if
Yeah, we
anything.
can, yeah, we can select more or less. It's more of like that we just see we have a number of ranges, right? Okay, wait, so we'll go there. So we have so many datas, we have hundreds of datas. So for every, like uh, it's like a range, so we are working in a range. If we have 130 to 200, just think about the number of data we'll be having if we are going to deal with every single number. And there will be so many numbers, like which like so many height values which doesn't belong to a category, right? So what we are doing is we are making a group of, okay, this is 130 to 134, in 130 to 134 height group, this number of people belong to. So it's more of like how we do the age categories. We, whenever you fill a survey, there will always be a pinning of data, right? Key or like 11 to 19 age group, 19 to 28, 28 to, so how you do is, because we have a certain category that after this age or after 60 65 years, the age above that is considered as senior citizens. The age group belonging to this categories are called youth, middle age group, children, teenagers, so something like this. Okay, so that is just for our convenience. Okay, you can
Means
obviously,
it will create a group of five.
yeah. So it's more of like it is creating a range of height. So 130 to 134. So how many people belong to, how many people have this height, and this height, this range height, 130 to 134. How many people belong to this range group? That's it. It's just a range group that is being created. Okay, you can
130
even,
to 134 in order, but what if the numbers were random?
sorry.
What if the numbers were random? Means it will create the random numbers in order. Then it will create a group of these numbers. Means suppose the numbers are randomly settled.
Haha.
So it hello.
Yeah, yeah, I can hear you.
Uh, the numbers were randomly stacked in order.
Yeah.
Then, if you are setting bin width as a 5, then it will create the number in sequence, that 130 to 130, 132, 133. Then it will separate, matlab it will create a group, or it will
No,
create a
no,
group randomly.
no. Okay, so the numbers are actually in random, right? But what it is doing is, it is just segregating the numbers. For example, it is calculating from, like, it is in haphazard manner. The data is in haphazard manner, and we have hundreds of data. So what it is doing is, it is categorizing it for our convenience. So what it is doing is, the height people belong from 130 to 134, how many people belong into this group? That's it. How many people? That
Okay,
is
okay,
giving
ma'am.
a
Okay.
count. 135 to 140, how many people? 140 to 140. This is what it is doing. That's it. Nothing else. Okay. You can even change the range. You can even keep, instead of 5, you can keep 7 or 10. Okay. Okay. So now we are calling naive Bayes class as NB class. Okay. So an NB class contain one or more feature classes, because we are seeing. So the name of the class has been given as NB class. So we are initializing with self name, and this is the feature. Why the star mark is there? Because that is variable. That is what we have to work on. Okay. So sometimes some people used to give this star features at, I'm so sorry, this star features, but it is not at all required. So this is just like initializing your features and names, that whatever it is, give it that itself. That's it. Self means the whatever the name has been provided, print it as it is, like that. Okay. So probability value for the given features are self. So the self is these things: features and names, features value, and the features. Okay. So this p value given feature returns the probability p, because that is what we are calculating, right? We are calculating the probability how the features is responding, for the feature value of the features to occur corresponding to p. This is the probability p, di and pj. So di is my the value that has feature variable of the feature I, like how the values are changing with the I, and p is the probability. Okay. So the features for the frequency of sum, we are initially categorizing it as 0. Then we are telling it, if that is the case, return it 0, or else you have to calculate it. So what we are calculating? We are calculating the frequency feature value, and we are calculating the sum of it. So that is what probability is, right? The event to be occurred divided by total number of events. So it's in simple term, it is the same thing. The event to be occurred divided by total number of event. Okay. So my NB class has been initialized. Now in this following code, we will create NB class with one feature. That is, we are just taking the height feature, because that is what we are working on, right? So we'll use the feature class of FTs. FT is what we have calculated up upper, like just now we have calculated above, right? So that is what we will take. So gender, in gender, we have already created the NP class. We are taking gender, so which gender it will belong to, and FTS is the height for it. Now the final step for creating a simple naive Bayes classifier is writing the, we are taking the classifier as class classifier. This, we are creating another class. We have created one NB class, and we are creating a classifier class. So we are calling again this NB class because it is again variable which we are taking from above, and this D again is the feature values that is being considered. So we are calculating the probability for each class, for each height. What is the probability for the overall class? Okay. So in all this, this is the probability values that has been considered. This probability list dot append means whatever the probability that has been taken, you have to append it into a list. You have to append it into a list. Okay, we are calculating the sum of it, probability values. If the probability sum is 0, the number of classes we are calling it the NB class. We want to know the length of it. Okay, and we are doing this appending of the number of classes. We are telling if the probability list is PL, which is, what is the PL? PL is my this probability, which is the reciprocal of number of classes. So we have done that. Now we will create a classifier with one class feature. Again, we are doing with height only, right? So we are classifying it either they either male or female. So I in the range 130 to 25, print what is the probability. Okay. So this is the probability that has been considered. So for the range 130, my probability for the male is 0, but the female is 1. That is, if the height is 130, it is 100% chance that it will be a female. If the height is 135, again, it is 100% chance that is female. But if the height is 140, it is 50-50% chance. This is what this probability has been calculated. This, for example, in 175, this is the probability. 77% chance that it is a male, and 22% chance it is a female. Okay. Now the question you must be having, that why we need to go for this complicated method with Python, and why we know how to calculate naive Bayes, we know how to do the calculation. So my dear friend, I would like to tell, because this is a very small example, a very small example. This is merely 100 datas with few features, like 2 or 3 features. But again, machine learning came into picture to handle not just 100 data but thousands of data. Okay, so what if this data is increased to thousands of data, or I would say, just think about a state data. So if you have to calculate, population of Mumbai is very high, right? Or even a city, not even a state. So Mumbai is a city, right? Its population is very much huge. So if you have given up survey data of Mumbai, and you need to do this kind of probability, you need to tell with the respect of height that this is the height, like I just we will tell ki 5 feet 5 inch. Now tell me how many male will belong to 5 feet 5 inch, and how many female will belong to 5 feet 5 inch of Mumbai city. So you need to do this kind of calculation. This is where it is of use. Okay, and this is just one example I'm telling you. There are so many examples where we need Naya bias classification. When we were dealing with COVID, so there were so many COVID portals that has been created, right? So how they were calculating these things on real time database, help with the help of these probability pythons only. Okay, so that is where it is needed. So that is where these kind of data set is needed, and these kind of predictions are needed, probability predictions are needed. These are not like accurate numbers, like 77%. You cannot say how many people or what people, but the percentage you are telling na. So this defines so many things. Okay. Okay, so there was just one parameter which we deal with, that was height. Now there are no person, neither male or female, in our learn set with a body height between 140 to 144, which we can see that. Okay, we saw that. This is the reason why our classifier can't base its result on learned data, and therefore comes back with a 50-50 result. You're getting it? Why it is coming at 50-50 result? That is why. We can also train a classifier with our first names. So we have the names, right? First name and the last name in the data set. So we want to now train our classify with our first name. You have to tell it with the help of first name. Initially, we did it with the help of height. Now we are doing with first name. So the first names features we are calling it is in gender. We have already created our NB class, that is naive Bayes classify. We don't need to create it again. We already have our classifier class, which is male and female. We just need to know the segregation, how it will work. So we are taking the test names as these names. These names are provided in the data set only. So there's so many names. We are just taking few of them. Okay. Now we need to know what is the probability that it will be a male or a female. So this is what we are doing. With the help of name, how can you tell if it is a male or female? So see, some examples it is giving 100% result. For example, Benjamin, Fred, Albert, these kind of thing, it is giving 100% result that it's a male or a female. Laura, female, Maria, female. But there are two names. Edgar, which is giving zero point 0.5 male, means there's 50% chances that it is a male, 50% it can be a female as well on the perspective of name. Similarly, there's a name called Jessie. In Jessie also, it is telling it is 66% chances that it's a female. Why this is like that? Just read this. The name Jessie is an ambiguous name. It's not clear that it's a female or a male. There are about 66 boys per 100 girls with this name. That is why there is chances that it can be a boy name as well. We can learn from the previous classification result that the probability for the name Jessie being female is about 2/3, which is calculated from our dataset person. Okay, which means there are more number of Jessie. Okay, so now see, we need to now know what are the numbers of name that is like which have Jesse as well. So the first name must be same, but the last name will be different, right? There's no name with the first name and the last name which is the same. That is hardly the case. That can happen as well, but mostly not outside. Okay. So what we saw that these are the first name. So we have one, two, three, four, five, six Jesse name with six different their surnames. So these are six different Jessies. Among them, there are four female and two male, and that is why that probability is like this. That is why it was giving 66% female, because the female is higher. Now you get it. Now, Jesse Washington is only 159 centimeter tall. If we have a look at the result of our classifier, train and heights, we see that the likelihood for a person 159 centimeter tall of being female is, so we need to see this 159 centimeter tall. So 159 centimeter tall belong to this range, 155 to 160, right? So what is the probability? 0.875 only. So probability that the person 155 to 159 is a female is 87%, right? So that is what it is talking about. Yeah, this is what it is talking about. Of being female is 0.875. So what about an unknown person called Jesse and being 159 centimeter tall? Is this person female or male? This is what our question is. Okay, that we have a name which we don't know is a female or male, and the height is 159 centimeter. To answer this question, we train the naive Bayes classifier with two features. Now we are taking two features, height and first name, both. Initially we took just height, then first name. Now we are taking both of them. We are again taking fit heights, names. We're doing pin with 5. So now you can see Jessie with height 159 centimeter. The probability that it's a female is 93%. And it will be a male, it's 0.06%. So what you will say? Yes, Jessie with height 159 centimeter will be 93% chances is there that it will be a female. Okay. Okay. So this is what naive Bayes classifier with like very like basic I'm telling you is the Python terms. There's something we will deal with scikit, which is just, library, and what we have dealing with. We just need to call and everything will be done. But before that, do you guys have any question? Like the one which we did manually?
No questions, ma'am.
Okay. So this is what we did was when we don't have any further libraries, um, it's not necessary that every time the library is taken for scikit will be giving good result. Sometimes what we have done initially is what is needed, because manual things are more required sometimes, and it is not even manual. They're like, we are going step by step. We are creating a classifier, a class classifier, a naive classifier class, and then we are segregating our data. So we're doing everything step by step, so we are very much assured that whatever result we are getting will be very, less probability that it will not a good result. But sometimes, if you have a small data set, you can always go with the scikit, which is the like pre-called libraries, or predefined libraries are there. So the same kind of thing which we have dealt with, yeah, I'm going to do with scikit library. So for this, I'm taking that again the same data set, the iris data set, the petal and floral, the data set which we are working on. So we're calling data set from sklearn, we are calling matrices. And there's again the predefined naive Bayes classifier, what we created earlier. It has already been there in the sklearn called Gaussian NB. So we are just calling it, we are loading our data set, we are fitting our model. These are simple steps. These are similarly the same thing which we have done. Okay, so calling the model, fitting the model with the data set and data set target. So this is the data, this is the target, and the printing the model. Now we need to know the expected. So expected is the target, and predicted is the data set that has to be like predicted with the target. Okay, and we need to know the classification report. So how we know the classification report? Expected and predicted, which means what is expected and what has been predicted. It is more of like what is the true value and what has been value been produced. Okay, so we are creating classification report and confusion matrices. This is the simplest one you can go for. So my model was Gaussian NB. That is what the print model that is printing. This classification report is this 012. So the three target is 012. What is the precision of that, recall of that? It is giving comparatively good result. Accuracy, it is giving around macro average 96, weighted average 96. And the confusion matrix report is this. So we were having three classes, right? So it is giving the diagonal reports we have to see 50, 47, 47. It's been pretty much good result. So this is the iris data set, is a very small data set. So you don't need to go for all the creation of classification and naive Bayes classes and doing the segregation of data, pinning of data, all those. Just go with the model, predefined library model, and you can do it. So this is another approach. Okay. Okay. So if you have any doubts, please let me know.
Ma'am, just one doubt.
Yeah.
In the naive base, we have imported the Gaussian NB
Yeah.
model.
Yeah.
So, is it an assumption that the underlying distribution is always Gaussian for naive base? Like, is it a
No,
predefined assumption?
nothing like that. Nothing like that. Why we always go for Gaussian? Because how my Gaussian curve is, it's a bell shaped, right?
Well,
Yeah, it's a bell shaped. So what we prefer is that our data is balanced. Balanced means the data is okay. What is balanced and unbalanced data set? Do you know?
balanced as in we have data for every given value, right?
Exactly. And unbalanced means they are like for the labeling data it will be more, unlabeling data it will be less. So what we are referring is, that is why we have considered caution. If you know, if your data set is not balanced or if your data set is something different, you have to take some other different naive bias. That's totally. But whenever we do with the balanced data, or we know the data sets are segregated and defined and everything, so we can go for Gaussian MB. That is default, like how we were dealing with kernels. So when we are dealing with kernels, by default we were taking RBF, right? We could take polynomial kernel, we could take different kernels. So this is something like that. Nothing as thumbs up rule. Okay.
Okay, got it, ma'am. Thanks.
Yeah. Anything else?
Ma'am, what is a confusion matrix? I
Okay.
Okay,
Okay.
yeah, I remember. Yeah.
It's like something you have asked at very last moment, because from very starting I have been teaching this thing. Okay.
Yes, yes, yeah,
Uh,
ma'am.
okay.
Yeah,
I'll tell you. Confusion matrix. Okay. Do you know when we do classification, what is we need is, okay, so there's something called true positive, true negative, false positive, and false negative.
yes,
Are you
ma'am.
aware of that?
Yeah, yeah, ma'am.
That is what confusion matrix
Yeah,
is.
yeah, I
That's it.
remember. Like,
Yeah,
sorry.
that's it, nothing else. Okay, I hope like you don't have any confusion about confusion matrix.
No, ma'am, no.
Yeah, okay, because these are the basic things you must know. Okay, let me stop presenting. Okay, so next week will be, I think, my final class. So let me know if you need some particular topic. Otherwise, I have thought of because we have worked with neural networks, and neural networks. I have just told you how neural networks, basics of neural networks, how you can create the nodes and the layers. And if you guys don't have any, suggestions for me for the final class, I could take an example, a real time example for neural network, and teach you that. So would it be fine for you?
Ma'am, one suggestion from me.
Yeah, yeah. Please.
Usually, while working with some scikit packets libraries,
Mm-hmm.
sometimes there are some errors like a value error or some warnings comes up
Mm-hmm.
because of the that 6432 bits kind of things. So if you just could explain some kind of issue within 30 minutes, it would be easy for us to understand and to tackle with such issues.
Okay, I will try to do that if I can.
Yeah.
Otherwise, I would suggest you, whenever
Hmm.
with Python, this is a very good thing. Whenever you have any kind of error now, this is what I do. So when I
Okay.
perform this on cloud platform like Google Colab and all, so whenever I
Mm-hmm.
have error something like this, I will directly go to Stack Overflow. So there's something called Stack Overflow. I'll just write on it, Stack
Okay.
Overflow. So in this, there are so many coders and programmers who have faced similar
Mhm.
kind of query or problem which you are facing, and they will be providing some solutions, and which most of the time work for me. If
Okay.
you cannot find it in Stack Overflow, whatever the error is now, just copy the error which you're if you're not able to figure out what the error is. It can be a
Mm.
runtime error, it can be a value time error, it can be any indentation error, any kind of error. Just copy that error, paste it on your Google, and see what kind of result do you get. Okay,
Okay.
I can assure you some results you will definitely go it, and this is comes with practice. Okay, you have to keep doing it again and again, and you will get to know, okay, this is the problem. Okay, I must have done something wrong with this. For example, like right now I was running the program and I saw, okay, my I needed to plot a chart and it is not coming. So definitely my plot library has not been called. First thing will come my mind is this. So I'll go again back, I'll see where I have called plot library, I didn't recall it, and then I'll do it. If again some error is coming, it will definitely show what kind of error it is. Okay.
Okay. And ma'am, one more thing that in final examination, if this coding kind of questions comes up now,
Yeah.
then it becomes a little difficult to remember the syntax and all the things. So can you suggest some way that way we can tackle it?
If I'm not wrong, in final examination coding, this recursive codings will not come. The basic things will come, like very
Okay.
basic will come. I can assure
Okay.
you.
Like, ma'am,
Yeah.
we should practice this assignment quiz question and not grade questions only, or we have to do something else also because we do not have any idea of these examinations at all.
I'm sorry, but I could not help you with this because I am not the one who is like into question preparation or
Okay.
Yes. So I
Like
would
ma'am, previous year, matlab previous term papers and all the.
sorry, I'm not aware of that. I don't have any access to previous year questions or how the question pattern will be. I'm really sorry about that. I may ask TAs, or you can just inquire in the like forum which has been provided. I think you will get solution, or you will get some assistant over there, because I'm not aware of it. I'm really sorry for that.
Last question from me.
Yeah, yeah, please.
For undirected graph, that graphical chapter sir has conducted in last week, I think.
Yeah, yeah.
So for that, can you suggest some reference book or any particular blog from which we get more clear idea about that? Because it's little bit confusing while understanding the basics of it.
I would just ask you to read more about Markov random field. So just read a lot about Markov random field. You can get sufficient material on internet. So I think that would be sufficient, I guess. Markov random field, MRF.
Okay.
Yeah. Okay.
Thank you.
Yeah. Thank you. See you in the next class.